May I start with a question? Who of you considers himself as a core developer? So developers who commit to the firmware, or to the drivers, really to the base of the firmware. You, Matt, you're one of the.
Yeah, I reckon there's a few of us here in the room.
Just please tell me just the name. I think it's good for me to know. So it's Matt.
Sure. Yep.
Yep. There and Sean as well. I was on before.
How about I can put it in a comment?
Okay, yeah, just put it in the comment. This is fine. Okay, so I would like to thank you for. I will take 10 minutes just to explain what Octoprobe is and what you can help me to make a good product out of it. So I would like to first quickly introduce me and my motivation behind it, then why we might need test automation, then about the Octoprobe tentacle. You see there is an octopus and an octopus has tentacles, and then how to write tests in PyTest, and at the end how you in Australia could contribute to really make a good thing out of it. Okay, about me. I'm using open source since a long time, and I'm very thankful about all these good products. And I admire very successful products, for example, MicroPython, but it also could be Docker, it could be Flask, and all these things. It's really cool. I'm very impressed. But now the question for me is, may I also contribute a successful project? How far am I able also to support something, to contribute something which will be used on a bit larger scale? And the question then is, what can I do? What the world is waiting for? There are many software projects for everything, but I don't want to reinvent the wheel. I would like to provide something which really is a big need. And this would but then be also a question for all of you. Is there a need for what I show you? Okay.
Hans, could I just ask, for the benefit of the video more than anything, could you make it full screen, the presentation?
I try. Okay. This one. Okay, and now?
Or the present view, I wonder.
The top right corner there.
Yeah, show.
There you go.
Okay, this is cool. Hey, thanks.
Thank you.
Okay, now why to do automation of the tests? So first, how we do it manually, we have a MicroPython board. Let's say we test here I2C. So we take a chip I2C and we connect a logic analyzer to it to see the signals. And here I name it feature under test. So here I test I2C. And so typically I connect all these components and then I can start testing. The problem is I have 11 different MCU families. So I can test on one, but as soon as I test on the second one, I have to plug it. And then also if one family, the family has hardware I2C and software I2C, it would make sense to test both. In the firmware, sometimes we have normal builds and we have multi-threaded builds. So it would make sense to test both firmware. And when we write the test application, then we could use sync IO or async IO. So when we multiply this, there could be 88 tests which could run. So 11 MCUs, hardware software I2C, normal and threaded, sync and async, so 88 threads. Everybody agrees somehow about these calculations, or I'm completely wrong?
No, that checks out.
Pretty close. Yeah.
Okay, now the red thing or the negative things of doing it manually. We have many combinations to test. There are many manual steps to connect these things to manually bring the board into boot mode to program it. It takes very, very long. It's not scalable. So if somebody did the test and he wants to introduce somebody else to do the test, it's not so easy to do. And it's a very frustrating task. At least from my experience, it's very frustrating to do manual tests and again and again. Okay. So we can agree on this?
Yeah, for sure.
Okay. Now, with test automation, so this is what I propose. We have different tentacles, one with a PyBoard, one with a Pico, one with an expressive. And all of them tentacles, they are connected to Octobus, to a bus. And there is a tentacle which I call potpourri because there are many different devices on it. In my example, it's one square C, it's one wire UART, and there is a duck connected to the bus. And now Octoprobe can install the software, the firmware on this PyBoard, and then run the tests. So just connect this to the bus and this, and then run the tests on the PyBoard. And then install the Pico, run the test here, connect this tentacle to the bus, run it here. So the goal would be that, let's say we could have 10 different processors connected to such a bus and automatically test it. So the green thing is now what I would like to achieve. It should be fully automated and it should be stable. Stable in that sense that if somebody writes a test who crashes or just does something silly, it should never crash the infrastructure. It should never be required that somebody goes there to recover the environment. The environment should run rock steady. So when you place it there, you switch it on and it should run. It's not so easy to achieve, but I think it's an important goal. Then it should be cheap. So a tentacle should be about $15 or 15 or 20 US dollars. So it would be easy for everybody just to quickly set up such an environment. And the product is open source and open hardware. So everybody can order these tentacles in China and have it the next week. It should be scalable in that sense. If somebody's running the infrastructure and we see there is more need, it should be easy for somebody else to just implement the same infrastructure and run it in-house. It should be adaptable. So not just MicroPython, also other MicroPython versions. It could be for Zephyr, for something else. And it should be fun. So it should be fun to write tests. It should be fun to run the tests. And typically fun has a lot to do with the quality of the source. It's no fun when there are always bugs and it's difficult to understand. So this is quite a challenge for me or for the ones who contribute this product, just to have a good code quality that everybody who is using it has fun. Okay. Okay, so far.
Good. Makes sense.
Now, let's dive into the hardware. These are 4 tentacles and the Octobus. So you see here this ribbon cable is the bus. So I just used components which are used by Raspberry Pi because they are available everywhere. They are cheap. So this bus connects all the tentacles. And so with such a setup, I should be able to automatically run tests. But now I can stack it. Let's say before we had it like this, but I can stack it, just put one on top of the other. So it's much a more compact form. So I think this way it's nice to go there with the scope just to develop on it. But as soon as it works, just to put one on top of the other and just leave it running. And such a board is about $20 fully assembled from China. Now let's have a look at the tentacle. There is one tentacle, and here we see the USB connection to the PC. And this connects to a USB hub, which allows power switching. This is one thing I learned in the news groups of MicroPython, that USB allows power switching, and I really love it. It's so cool. So with this hub, I connect a Raspberry Pi Pico here on port 1, so I can power cycle the Raspberry Pi Pico. On port 2, there is the boot button. So when I power on port 2, I can power on the Raspberry Pi Pico and will boot in programming mode. This is how I can automatically program it. Then port 3 is this USB hub, which I use to test or to power the device under test. And the last port is here to have an error LED. So sometimes if a test crash, it would be nice just to indicate, hey, this is the port which gave the troubles. Okay, then we have a Raspberry Pi Pico, which controls this infrastructure part. And the important thing of the infrastructure part are here 5 relays. And you see here the relay. So relay 1, you just can connect to these 2 pins, relay 2, relay 3. And now you know the P board and you see where this wire goes. Now the question is, what does relay 1 do? You know what this pin is? Who is the first to find out? That's the boot pin.
Makes sense. Yep.
So here the boot pin connects to relay 1 and then it connects to 3.3 volts. So when I close relay 1, the P board will boot in programming mode. When relay 1 is off and I power cycle it using the hub, then it will boot in application mode. And now I used other relays to connect, let's say 1²C to the Octobus. And you can't see the connections because they are on the back side of the PCB. So you just can use this relay to just connect whatever you require to connect to the bus. And here you can mount whatever device you want to test. Okay, questions so far about this? Okay.
I think we're all good.
Okay. Now, the other side, how to write test on such an infrastructure. I was using PyTest, but it shouldn't be limited to PyTest. There is a test setup here. I take the MCU tentacle, I have the duck tentacle, the device tentacle, and I switch the relays 2, 3, 4. I close them because I know how the relays should be, that they should be closed, that at the end all the wires are connected correctly. So I have to look at the schematics to know which relays to close. This is the test setup. And then I write the MicroPython program, which I import 1 wire and I connect to 1 wire, and then I do a scan on 1 wire. And then I get the numbers of connected devices, 1 wire devices back. And at the end, I just do the assertion to verify if I see 2, because I know I connect to 1 wire devices. And now here you see this trigger pin. The trigger pin goes to 1 and then to 0. This allows me to automatically take shots with the data acquisition. I just trigger for this line and then I see how the scan is done, and then, yeah.
Yeah, so yep, makes sense.
Okay, so you see all tests is everything is written on the PC, but some fragments of Python, MicroPython code is sent to the processor, and I use MP remote for this. but this is all questions if this is the best solution. I just started with what I thought the best, but this is something I'm interested to really know if I was choosing the best solution. Okay, now PyTest again. Test discovery. So here we didn't have the signature of the function. This is now the signature of the function. Here, so if you don't know PyTest, you're lost here. But this is a PyTest fixture where I can say this test is testing the feature on the test one wire. And it requires an MCU tentacle, it requires a potpourri tentacle and a duck. And then when I enter the code, you see it here, then I have these objects with code completion. And because I added them, it will have an influence on the test discovery. So when I look at the discovery browser of PyTest, I see I have this test one wire. You see, it's this one. And it uses 3 tentacles. And I see here it was choosing one tentacle with the PyBoard. This is the serial number of the tentacle. Then it uses the potpourri and the duck. And then it did the same test with the Raspberry Pi Pico, again with potpourri and duck. Who knows, or is this new for you, PyTest, test discovery?
I know PyTest pretty
What-
well.
Yeah.
Yeah.
Well, they're not for
I think-
not for hardware stuff,
Yeah.
obviously.
No, I think most of us have used, well, most of us. I'm
So
speaking-
I didn't
A
get
lot of us have used
the
PyTest.
answer. Was this a yes or a no?
Yes, have used
Or it
PyTest.
might be. Okay. Now I would like to do a real demo on Visual Studio Code.
Oh, God.
So this is Visual Studio Code just out of the box, and Visual Studio Code out of the box has this PyTest Explorer. And I can jump to a test. So this is one test, and this is another test.
Oh, he does not.
And
Yeah.
I can, let's say, set a breakpoint and can run it now. It will power cycle the PyBoard. It will verify if it contains the correct firmware version. And then it will start the test. And so this is how I could debug it. And here I can, yeah.
The breakpoint. Yep.
And now when you look at the 4 tests, they take about 20 seconds to run. That's just the current state.
There's a lot going on.
It's not really ready to be really used. Okay, but now let's say I would like to write another test, one for the UART. I just take the signature of the test. I say this is now test UART X, and I would like to test the feature UART. And now when I save, you will see how it updates the test explorer. Now you see that here I have the tests. The same would happen when I add new tentacles to the infrastructure with another processor. They also would, these boards would pop up. So this is one way I would think it would be sexy to develop tests. And when they are developed, then they should run automatically.
Yeah.
Okay. Now, so the big question for you guys, is this something the world is looking for? Or do I do something which is not really needed? And the other question, I think it would be good to have more people in the team to have more feedback. So currently Matt did technical reviews, and if it's okay for you, Matt, I think we keep like this.
Sure.
then who would be interested to run GitHub runners? So the goal would be that when you build the firmware in GitHub, it should be possible to add a GitHub runner which runs, let's say, the tests here in Switzerland.
Yeah.
So who would be willing just to test
Did you share it?
such a runner? Then who would be interested to write some tests to give me feedback if this makes sense? So somebody who has a real problem and who would like to solve this problem with tests to have a better test coverage. So in the first go, it could be done remotely on Visual Studio Code. So when I have here an infrastructure, I could provide remote access to Visual Studio Code and you could test it remote. And when you think it's something useful for you, you could build up your own hardware and test it in-house. And then the third question would be, who is interested to get some hardware? For example, 10 tentacles, just to build everything up. And yeah, that's what I plan to do now. The question is, what's your feeling about it? How should we continue? You're
Yes.
seen, huh?
Yeah, it's me.
Okay.
Sorry, Matt just had to step out because the pizza delivery has arrived.
You're one of the core developers.
No, I'm
Okay.
not just enthusiast.
Okay.
Although I am also a firmware developer in my day job. Although unfortunately not with MicroPython. But I would
when you
certainly
develop hardware in your day job, could Octoprobe be something which you also could use in your daily job?
Yes, and actually, as you were going through this, I absolutely think it would, because we've all got, for example, I mean, it's for C code, but we have unit tests that run, just as unit tests running locally
on the device.
No. So just running, on a host PC, but having, and I suppose it wouldn't necessarily even be. Well, in fact, that would be so for the most useful thing for the work that I've got at work at the moment. I guess I would love to perhaps have a way to run. It might not be a MicroPython application on the device under test, but to run any application, it could be like a C compiled, like a binary of some sort, but write the tests for that in PyTest. That would perhaps actually also be.
With Octoprobe, you can test the test how you would write it. You're not fixed limited to MicroPython for the test. You're just limited to MicroPython for the infrastructure. But on the device under test state, you just can compile your firmware and
whatever binary,
put it there and test it. You need some communication with it, but typically it's you communicate using USB to the device under test.
Okay. Yeah, I'm with you now. No,
so
that would
for me the goal would also be if you developers can use Octoprobe in your company, just because I think it's something which is new, that you can get it so cheap and so fast, the test environment up and running. So
yeah, I actually I'll have a chat with some of the guys at work tomorrow about it, in fact, because I do think that this would be it's often something that we've contemplated and never really tried to start doing, right? Because it's obviously we're all, you can think of how it could be done, but unlike with software unit testing, where there's plenty of frameworks already there, set up and relatively easy to get going, I haven't really seen anything like Octoprobe for doing a similar kind of thing, but with hardware testing. So yeah, I definitely see pretty big use case for this at work.
Yeah, definitely. Like places I've worked before, it's been like.
May I ask somebody here in the group who is really working on who is distributing to the firmware and really has this whole load to do testing?
Yeah, so a place I've worked previously with Sean, actually. It was like
Sorry.
Hardware in the loop testing was always something that was discussed and wanted to be done, but because the conversation never went beyond how it could be done, and you've got to, we were doing contract design, so factoring it into commercial projects, you need to be able to cost out what that would look like. And because we didn't know how it would do, no one wants to fund an exploration phase for that, at least for us. Whereas if we'd said, oh, we're going to use Octoprobe, it'll cost $50 in hardware and we'll do it like this and take a couple of hours, that would be greatly beneficial for the project. So I can definitely see the value proposition for like both people running stuff at home that they want to work better and for commercial projects.
Okay. Pardon me, what's your name?
I'm Oliver. I don't actually work in hardware space anymore. I've abstracted myself away from it, but I just like to keep involved.
Okay. But say again your name, Oliver.
Yeah, it's in the
Okay.
message Matt sent in the chat.
Okay, cool. Okay. So thanks a lot, everybody, for the attention.
Yeah,
It was a pleasure to present it, and let's see how we continue with it. Enjoy your pizza.